Hello, in this video we will show how to compare two variances using ftest in R. So comparing two variances is very important because very often we want to compare two sample means, but it requires that two samples cannot have very different variances first. If they have very different variances, so it's meaningless to compare the mean, right? So comparing the variance is one kind of ANOVA, analysis of variance. And if we want to compare or test if the variance are different for the two samples, we have to divide the large variance by the smaller variance. So if the ratio of the division, if the ratio of two variances are very larger than 1, so we can be confidently to say that the two variances are not the same, right? So first we have a null hypothesis, saying that the two variances have no significant difference. Then we will test from the sample. If they are very large difference, then we can say that we will reject this null hypothesis, right? So this is called ftest. This is called ftest, or say the Fisher's ftest. Then we look at this figure. So this is a curve of, or say the ratio of two variances. So this is like any probability density curve. So this is the critical value from the F distribution. So if we get the ratio of two samples variance, if this ratio two sample variance will larger than this critical value. This critical value is from the F distribution is we assume that if there are 0.05 for the probability on the right side of this critical value, then if we get the sample ratio larger than this critical value, so which means this sample ratio statistic will be located in this blue area. So this is the rejection area. So this is one way to test for comparing two variances. Another alternative is we can just get the probability of getting such a larger difference between the two variances. If this probability is very small or smaller than 0.05, we can also reject this null hypothesis. So this is called a p-value test. So in R, we can use, for the first method, we can use the QF function. So QF, what is QF? Q means the quantile. F is for the F distribution. What is the quantile? Quantile actually is this critical value. So for distribution, if we set 0.975, so this means the right side or left side, the white area of the critical value. So if we want to make a two-tailed test, because if we have any information such as which one variance will be larger than the other one, so this is called a two-tailed test. But if we have some prior information such as one variance is larger than the second variance, but we have not so confident of that it is critically or significantly large, right? So this is called a one-tailed test because we know one could be larger than the other one. So this is called a one-tailed test. For example, in the one-tailed test, we can use QF 0.95 because we only will test 0.05 probability on the right side. So on the left side is 0.95. But in a two-tailed test, the test area can be on both sides. So on the right side, we will divide the 0.05 by 2. So the left side will be the 0.975, right? And this 99 is in the example that we have in the 10 observations in both sample. So the the degrees of freedom is 9 and 9, right? So next we will show how to implement such an example in RStudio for the ftest. So first we set the working directory, and we can load a data code from this CSV file, then read this CSV file into a data frame. So this data frame ftest data. We can show this data. Actually, it's a very simple data. Has 10 rows, 10 observations, and with 2 columns. Column A is garden B, and column 1 is garden B, and column 2 is garden C. Then we will attach this data frame because that will be easier to just use the variables, and we can show the names of the data frame, called 2 columns, garden B and garden C. So next we just use the variance of garden B, 1.33, and the variance of garden C is 14. So this could be significantly larger than 0 if the ratio between garden C and garden B, right? It's a very big difference. So we can use the QF function for the one-tailed test. So QF 0.9599. This will calculate the sample statistic with a quantile value. So we will calculate a quantile value like this. We'll compare with this critical value, right? So this is the critical value for the 0.95. So this means the blue area has 0.05 probability, and we will calculate this critical value. Then compare the sample ratio with this critical value, right? So we can just run QF 0.95, and both degrees of freedom are 9 and 9. So this critical value is 3.17. So look back, which means here is 3.17, and will return the probability on the right side of this critical value is 0.05. And because our F ratio from the sample is the division between garden C and garden B's values. So this value is 10.66. It is much larger than this critical value. So which means we will reject this null hypothesis that the two variants are not significantly different. Or in other words, we will conclude that we have 95% the confidence to say that the variance of garden C is larger than variance of garden B, right? And another alternative is just to calculate the p-value from the sample. So p-value from the sample, we can use a PF function. So PF is actually to calculate the cumulative probability upon this quantile value. Here we use the sample variance division here. Then we will calculate the left side's probability using PF. Then we use 1 minus this left side's probability, and we'll return the right side's probability from the sample. So here the PF is the white area probability of getting such sample F ratio in a F distribution, right? Then we will use 1 minus this cumulative probability. We'll get the right side of this quantile value. Run. So this is very small, 0.008. So which means we will get the blue area in our sample is very small. So we will reject this null hypothesis, right?